This video will cover the bottom flap of section number 4 of your Unit 9 circle flipbook. The essential question for this section is, how do you find the area of a circle sector? Now, remember our previous video class, we were looking for how to find the length of a piece of the circumference. So the whole circumference, I want to know, what is the length of one piece or one arc? And in the picture or the question of a pizza, it's how long was the crust on a particular piece. So if you want to think about it that way. Now, in this video, we're going to talk about area of a circle and how do you find out the area of a particular part or a particular sector of a circle. So a sector is just a part of a circle, but it's made by a central angle, just like we make arc lengths out of central angles. Alright, so how do you find the area of a circle sector? First thing you better remind ourselves of is how to find the area of a whole circle. So in this particular example, let's do the same thing we did before. We're going to go ahead and draw a radius. The area of a whole circle is found with the formula area equals pi r squared. Pi is a number class, not a variable. It's a number. It's a ratio, actually, found from a circle. You define that in section 1 of your flipbook. Pi is the ratio of a circle's circumference to its diameter, and then r is the radius. So if the radius of this circle is 8 feet, then the area is pi r squared, or pi times 8 squared. We can go ahead and do 8 squared. 8 times 8 is 64. We always put that in the front. We put pi last. So the area of this particular circle is 64 pi, and our unit of measure is feet. Now, just like arc lengths, we have an exact answer for this, which is in terms of pi. You leave pi as a symbol. 64 pi feet, that's the exact answer for the area of this circle. The approximate answer is found by plugging in 64 times pi in your calculator and pressing equal. And we've got 201.06. We'll round that to 201.1. So 201.1 feet is the approximate area. It's not the exact answer. Once we put pi in our calculator, we are getting an approximate answer because pi does not have an exact value. The decimals go on forever. All right, let's go ahead and apply this now. We now know how to find the area, or the inside. Oh, you know what? I just realized something, class. I'm doing area and I'm giving you a unit of measure that's not area. This is 64 pi, and that's in feet squared. This is 201.1 feet squared. So area is in squared units, and that's the space taken up inside this circle. All right, let's get going on this. Here's our first question. What is the area of sector ABC? Well, we better create a sector ABC. So let's do that. I'm going to put some radii in here. Let's go ahead and label A, B, and actually, you know what? Let's label it this way. A, B, C. And let's say that we know that the degrees of this angle ABC are 88 degrees. Let's say the diameter of this circle is 3 centimeters. And the question is, if we know the entire area of the circle, can we find just the area of this space right here? Looks like a pizza slice. What's the area of just this space? And we're calling that a sector. So that's what a sector is. What is the area of that sector? Well, let's first find the whole area. The whole area of the circle is pi r squared. That's pi times radius, which is 3 squared. And that is equal to 9 pi. 3 squared is 9, so 9 pi centimeters. That's the exact area of the circle. Now, just like we found the length of an arc, we can use the same kind of proportion to find the area of a sector. This symbol here, class, stands for sector. It looks like an upside down triangle. Think of it like a pizza slice. It looks just like this shape, kind of, sort of, I guess. So the area of this sector ABC is found by the sector ABC over the entire area of the circle. And you know what? This is not supposed to be a 6. This is supposed to be a 9. So let's do this. The total area of this circle should have been 9. Let's correct that. So correct that. The area of the sector ABC over the area of the whole circle is equal to degrees of sector ABC over the total circle degrees. So we set it up exactly the same way as finding an arc length, except for now we're showing the sector ABC on top of this ratio and the total area on the bottom of this one. But now we solve it exactly the same. Let's cross multiply. We've got 360 times, I'll put this in parentheses, sector, oops, that's a right side up triangle. It's going to be an upside down circle. Sector ABC is equal to 88 times 9 pi. We can simplify the right side. 88 times 9. Let's go ahead and do that now. I don't have these recalculated out, so I'll do these real quick. 88 times 9 is equal to 792. So 360 times sector ABC is equal to, what was that number again? 792 pi. And the last thing we're going to do is divide both sides by 360. So now we're going to get sector ABC is equal to 792 pi divided by 360. There is our exact answer as far as the area of that sector. We're going to go ahead and plug that into our calculator and get an approximate area. 792 times pi divided by 360, and we've got about 6.9. So approximately 6.9, and remember our unit of measure for area is going to be square units, so centimeters square. 6.9 centimeters square. So you can see a lot of similarity between this and finding an arc length. Again, the only difference is we still do our ratio of the degrees of our sector over the total degrees of a circle, but our other ratio is what we're looking for, the area of sector ABC, and now it's over the total area of the circle. All right, let's go ahead and do the next one. You can see this actually works pretty good. Once you learn how to do arc length, sector area is pretty easy. What is the area of sector AEC? Well, let's go ahead and draw. Oops, that's not going to work. Let's go ahead and draw our divisions of our circle up. So we're going to do similar to what we did before. Let's do a diameter. We'll pick up 2 other radii in here. Let's go ahead and label our points on the circle, A, B, C, and D. Let's say that this is 60 degrees, and this is 95 degrees. This is 35 degrees. Notice those add up to 180 degrees because AD is a diameter. And let's say that this circle has a 10-inch radius. All right. So what is the area of sector AE? Oh, I forgot to label E. Here's E right here, the center of the circle. What is the area of sector AEC? But before we do that, class, again, we're going to have to find the measure of the 2 arcs that are part of that central angle. It's including AB and it's including BC. We're going to have to add those together. So 60 plus 95 is equal to 155 degrees. What's the whole area? We've got to know the whole area of the circle. Area equals pi r squared, which is pi times 10 squared. Remember, we put pi on the end. 10 squared is 100. So 100 pi, and our unit of measure here is inches squared. Now, did I fix that before? Nope. Look at our previous example, class. Will you make this centimeters squared is our area of the whole circle. So 100 pi inches squared. And now let's just find the area of sector AEC. We'll write a proportion. Sector AEC over the entire area of the circle, which is 100 pi, is equal to the degrees of sector AEC, which is 155, over the total degrees of the circle. Notice these ratios, class, kind of cool. This is just the ratio of the degrees of the sector over the total circle. This is just the ratio of the area of the sector over the area of the total circle. Now let's go ahead and use our rules of proportions. Cross multiply. We've got 360 times sector AEC is equal to 155 times 100 pi. Let's go ahead and simplify this. 155 times 100 equals 15,500. So this is going to be 360 times sector AEC is equal to 15,500 times pi. Now we can divide both sides by 360 degrees, and we're going to have sector AEC is equal to 1,000, I gotta fit this in here, sorry, 15,500 pi over 360, and that's our exact answer. Let's go ahead and change that to approximate. Let's put that in our calculator. I'll move this over so we can see it. We've got 15,500 times pi divided by 360, and our final answer is 135.3, approximately 135.3 inches squared. So just these two pieces right here, this sector AEC is equal to 135.3 inches squared. Last one, let's take a look at our pizza. A pizza with a 22-inch diameter. We're going to divide that into 6 equal pieces. Do our best to divide it into 6 equal pieces. Remember, class, we know that all we're going to be looking for now is we're going to be looking for the area of one of these sectors. One piece of the pizza. Alright, if the pizza is 22-inch diameter, that means the radius is 22 divided by 2, which is 11 inches. The area is pi r squared. That's pi times 11 squared, which is 121 pi inches squared. There's our area. Now in this case, we don't have to set up a proportion because we know this pizza is divided into 6 equal slices. All we have to do now is take the total area and divide it by 6. So again, class, if you get a circle and it tells you you divide it up into equal pieces, then you don't have to write a proportion anymore. Now you could. It's going to be the exact same answer. This is a shortcut to that. Let's go ahead and plug that in. 121 times pi divided by, remember that's our whole area. We're going to divide that 6 different ways. Oops. Let's clear that. 121 pi divided by 6 equals 63.35. We round that to 63.4, approximately 63.4. Remember, this is area, inches squared. Now I got about 30 seconds. Let's find out how much area the whole pizza is in approximate answer. That's 121 times pi equals about 380. So you can see 380 square inches for the whole pizza, 63.4. It better be less than that because we're only just taking one piece. So there is a shortcut to finding just the area of a pizza slice. The other examples show you how to find the area of any sector if you know the degrees of the central angle.